Welcome back, everyone. It's now time to test your new skills with a capstone project. What we're going to do is we're going to put all your current skills together with Pandas, NumPy, Matplotlib, and Seaborn together with a very fun and hopefully enjoyable capstone project. And this project is actually going to take us all the way back to some data from 2015. But before we begin, let's quickly review our machine learning pathway to understand where our skill set is currently at. Recall in the machine learning pathway, we're starting from the real world, and then we have two main approaches. Either we're trying to solve a particular problem, like how do I fix or change X, or there's a specific question we're trying to answer. Maybe how does a change in X affect Y? And right now, we actually have the skill set necessary in order to perform basic data analysis, which recall, we start from the real world, we collect and store data, clean and organize that data, and then perform exploratory data analysis to produce a report, visualization, or communication. And in this case, we already know about Jupyter Notebook, NumPy, Pandas, Matplotlib, and Seaborn, all the Python tools necessary in order to perform basic data analysis, which will allow us to make decisions or answer key questions. And at the heart of this capstone project is the question we want to answer, which is there a conflict of interest for a website that both sells movie tickets and displays review ratings? To understand the context of this question, let's go ahead and travel all the way back in time to the year 2015. So it's the year 2015 and you're looking for something to do on a Saturday night, and you decide to go see a movie. Now luckily for you, instead of having to drive all the way to the movie theater and buy your ticket for a show that's happening later that night, there's a website called Fandango, and Fandango sells movie tickets online. However, you don't actually know what movie you want to watch yet, but luckily for you, Fandango also displays movie ratings. So they both sell movie tickets and they're displaying movie ratings on the same website. So you're browsing the Fandango website, seeing what movie you should buy tickets for on their site. And keep in mind, Fandango is going to have a surcharge on top of the ticket price to make some money off this transaction, which is fair enough since they're providing a service of selling tickets online. So you take a look at the Fandango website, and you see that Taken 3 has a 4.5-star rating on Fandango. And this is based off of real data from what their site looked like in 2015. So, to say the least, you go out, you buy the ticket on Fandango, and you watch Taken 3, and you may have been disappointed by the film. And if you want a little more background on why this is, you can go ahead and just Google search Taken 3 fence jump scene to get an idea of what the film is like. So, you begin to ask yourself, is there a conflict of interest for a website that is both selling movie tickets and displaying review ratings? Can I answer this with a data analysis? Well, for one thing, it should be noted that it probably doesn't bode well for Fandango when their Wikipedia article literally has a controversies section for what should be a pretty simple business of just selling tickets online. So for this capstone project, we're actually basing this off of a fantastic article that came out in 2015 called Be Suspicious of Online Movie Ratings, Especially Fandango's, which came from the website 538. So the question we were trying to answer was, is there a conflict of interest for a website that is both selling movie tickets and displaying review ratings? More specifically, really what we're asking is, does a website like Fandango artificially display higher review ratings in order to sell more movie tickets? So recall that in the machine learning pathway, what we have here is a data analysis problem. We need to collect, clean, and organize data and perform exploratory data analysis in order to create some sort of report or visualization to answer this quick question. And so what we'll be doing is we would have already scraped some reviews off of many websites for you, and then you'll be using Pandas to organize and use Seaborn to explore. So after you use Pandas to organize the data, reformat it, and Seaborn to visualize and explore it, you should be able to answer the question, does Fandango display artificially higher than average reviews? Now there's a couple things to notice before we actually jump to the notebook and do an overview of the project, is that Fandango, interestingly enough, has two ratings. It has a stars attribute and then a rating attribute. And stars is the rating in stars that go from 0 to 5 that's actually displayed on their website's HTML. And this is what someone would see if they just visited the Fandango website. But then there's an actual rating, which is the true rating that Fandango holds for that movie. So what that means is they may be showing someone a 4.5-star visual rating when they fill up the star meter, but in the background, maybe it's just a 4.3 that they happen to round up. So first what we're going to do is we're actually going to compare the true numerical ratings that Fandango holds on its backend against what it actually displays to users. And then we'll see if there's any discrepancies there. Then what we're going to do is compare Fandango's ratings to other rating websites such as Rotten Tomato or Metacritic and see if there's a skew towards rating movies with higher ratings. Alright, so here we are at the Jupyter Notebook. Underneath the 𝒂𝒐 project folder, there are two notebooks. One is the capstone project, and the other is the solutions notebook for the project, which we're going to be going through in a series of lectures after this one. You'll also notice that two CSV files necessary for the project are also located here. So if you decide to start this project in another location, you'll need to provide the full file path to these two CSV files in order to use them. So let's check out the capstone project. And as I mentioned, this whole project is based around this article from 2015 from the website 538. So what we have here is just tasks in bold for you to complete. And your first task, I would hope, is that you actually read the article. It's linked for you right here. And it's a really great article on 538. Basically, they kind of prove statistically that the conclusion to Fandango pushing scores higher is actually true. And after you read this article, what we're going to do is duplicate its findings with Python. And we'll actually create our own versions of the plots shown here. Notice there's a really lopsided rating curve for Fandango, so a lot of movies are rated quite high. So as we come back to the notebook, the first part is once you read the article, we're essentially going to go through the data ourselves. And there's two main CSV files that we're working with. The first one is this all sites scores.csv, and that contains a bunch of scores, not just from Fandango, but also Rotten Tomatoes, Metacritic, IMDb, etc. And then we have this Fandango scrape.csv, which contains a bunch of information scraped from Fandango. The main thing to note here is that there's both a stars and rating on Fandango. And essentially, the stars are the number of stars presented on fandango.com to someone just viewing the website. And then the rating itself is the Fandango true rating value for the film. So basically, the number of people that are visiting Fandango, they go ahead and vote a rating on the film, and then that rating is transformed using HTML to some sort of visual representation of stars. So the first thing we're trying to answer is there a discrepancy between the numerical rating Fandango holds versus the stars it shows people visiting its site? So this is where part 2 comes into play, where we begin exploring the Fandango displayed scores versus the true user ratings on Fandango's own site. So we'll ask you to do a bunch of visualizations and calculations on the data frame. You'll explore the relationship between the ratings versus the number of votes. You'll see if there's correlation there. And eventually, after you perform other things like creating a year column, analyzing which movies are the most popular, which movies have 0 votes, the main idea is that we'll eventually create that first visualization where we're going to compare the true numerical rating by users on Fandango versus the stars displayed. So what we see here is, in fact, the stars displayed is skewed higher than the true numerical rating, which means that the stars shown overall are going to skew and show users a higher rating than the movie actually achieved. Now, this could be fine if you're just rounding to the nearest 0.5. Maybe movies in general, they score something like 4.3, and Fandango happens to round them up to 4.5. This discrepancy itself is not the whole story. It could be perfectly reasonable for there to be a discrepancy just because they happen to round up. So what we want to do after this is quantify this discrepancy and begin to explore what movies, or on average, are there a star difference between the user rating versus what's shown to the user. And you have a bunch of tasks to perform in order to explore that. Which brings us then to part 3, where we're going to be comparing all the Fandango ratings to other sites like Metacritic and Rotten Tomato. So we have then two data frames we want to work with, and eventually you'll join these together after exploring the other websites individually. You'll explore Rotten Tomatoes, and Rotten Tomatoes has both a user rating and a critics rating. So we'll do a little bit of exploration on user ratings on Rotten Tomatoes versus critic ratings on Rotten Tomatoes, but in general they tend to line up. We'll explore what movies have big differences between them on Rotten Tomatoes, essentially what movies did critics love that users did not, and what movies did users love that critics did not, and we'll kind of list them out here for you. You'll do a little bit of analysis on the Metacritic data as well as the IMDb data. But after that, we kind of switch back and move to our main story, which is the Fandango scores versus all the other sites. So you'll use what you know about pandas and merging tables together to merge those two data frames. And eventually you'll also have to realize how to normalize scores, because certain ratings like on Rotten Tomatoes go from 0 to 100 instead of a 0 to 5-star range. So you'll calculate how to do that. We gave you some hints on how to do it kind of in a more complex way or a more simple way where you could just do something like 100 divided by 20, that's equal to 5. So kind of a big hint on how to convert stuff. And eventually you'll get this data frame with these normalized scores for you to do a comparison of the distribution. And your final results will essentially be visualizations where we're comparing all the normalized scores across all the websites. And we can see here still this stars and ratings. So stars here in red is actually the stars being shown on Fandango. By far, it's skewed much higher than every other site, which means even in comparison to other sites, Fandango's stars displayed is not just higher than the rating it holds numerically on its site, but it's even much higher than all the other websites. So clearly Fandango is pushing scores and ratings higher. And what we'll eventually do is create this distribution plot that compares the Rotten Tomato critic ratings versus the stars displayed on Fandango. And here the results are quite telling. Rotten Tomato critics in general have a pretty uniform distribution. There's as many bad movies in their opinion as there are good movies. But for Fandango, there essentially are no bad movies, and almost all movies are rated above 3 stars. And there's also this optional thing of creating a histogram out of the normalized scores. Then you'll explore the worst movies rated across all platforms using a Seaborn cluster map, which you would think in general would cluster bad movies together and then good movies together. But there is such a differential between the stars shown versus the bad movies that here you can clearly see on a heat map, here in this dark purple section, these are low rated movies, but when you jump over to stars and rating from Fandango, they don't need to be nearly as dark, which is kind of interesting. That means there are some movies that across the board, here in dark purple, that everyone's rating badly, but Fandango themselves is rating them just mediocre at worst. And so clearly we realize Fandango is rating movies, so we begin to explore what are the top 10 worst movies according to Rotten Tomatoes critics, and what did Fandango say they were. And eventually you'll realize that the kind of worst offender here is Taken 3, where Taken 3, Fandango actually displayed 4.5 stars as their rating for this movie, when if you were to average out the scores on all the other websites, both between users and critics, it gets an average rating of 1.86. And the Wikipedia for Taken 3 is also not super generous on the critical reception to the movie. Okay, so if you enjoyed Taken 3, no offense, but most people disagree with you. However, Fandango would have agreed with you by displaying 4.5 stars. I hope this is a really fun project for you, and coming up in the next series of lectures, we'll work out the solutions. I'll see you there.